Anamorphic format is the cinematography technique of shooting a widescreen picture on standard 35mm film or other visual recording media with a non-widescreen native aspect ratio. It also refers to the projection format in which a distorted image is stretched by an anamorphic projection lens to recreate the original aspect ratio on the viewing screen. The word anamorphic, and its derivatives stem from the Greek words meaning formed again. As a camera format, anamorphic format is losing popularity in comparison to flat formats such as Super 35mm film shot using spherical lenses. However, because most movie projectors use anamorphic projection format, spherical format negatives are commonly converted into anamorphic prints for projection. In the years since digital cinema cameras became commonplace, anamorphic has experienced a considerable resurgence of popularity, due in large part to the higher base ISO sensitivity of digital sensors which allows shooting at deeper stops. History and development. History The process of anamorphosing optics was developed by Henri Creux copyright 10 during World War I to provide a wide-angle viewer for military tanks. The optical process was called hypergona by Creux copyright 10 and was capable of showing a field of view of 180 degrees. After the war, the technology was first used in a cinematic context in the short film Sans Tour en Vue in 1927 by Claude Haut and Lara. In the 1920s, phonograph and motion picture pioneer Leon F. Douglas also created special effects and anamorphic widescreen motion picture cameras. However, how this relates to the earlier French invention, and later development, is unclear. Anamorphic widescreen was not used again for cinematography until 1952 when 20th Century Fox bought the rights to the technique to create its CinemaScope widescreen technique. CinemaScope was one of many widescreen formats developed in the 1950s to compete with the popularity of television and bring audiences back to the cinemas. The Robe, which premiered in 1953, was the first feature film released that was filmed with an anamorphic lens. Development The development of anamorphic widescreen arose due to a desire for wider aspect ratios while maintaining the use of standard cameras and projectors, and maximizing overall image detail. The modern anamorphic format has an aspect ratio of 2.40 to 1, meaning the picture width is 2.40 times its height. Academy format 35mm film has an aspect ratio of 1.37 to 1, which is not as wide. In non-anamorphic spherical widescreen imaging, the picture is recorded on film so that its full width fits within the film frame, but substantial film frame area is wasted on portions that will be matted out by the time of projection either on the print or in the projector, in order to create a widescreen image in the theater. To make full use of the available film, thereby increasing overall image detail, an anamorphic lens is used during photography to stretch the image vertically to fill the full frame. Up to the early 1960s, three major methods of anamorphosing the image were used: counter-rotated prisms, curved mirrors in combination with a principle of total internal reflection, and cylindrical lenses. Whatever the method used, the anamorphic lens leaves the image on film looking as if it had been stretched vertically. This deliberate geometric distortion is then reversed upon projection, resulting in a wider aspect ratio on screen than that of the frame as recorded on film. An anamorphic lens consists of a regular spherical lens, plus an anamorphic attachment that does the anamorphosing. The anamorphic element operates at infinite focal length, but still nevertheless anamorphoses the optical field. When an anamorphic attachment is used, one uses a spherical lens of a different focal length than one would for 1.851, and then the anamorphic attachment squeezes 2x horizontally. Specialized reverse anamorphic attachments existed that were relatively rarely used on projection and camera lenses to expand the image in the vertical space, so that a frame twice as high as it might have been filled the available film area. Since a larger film area needed to be used in order to record the same picture, the quality was increased. The distortion introduced in the picture must be corrected when the film is played back, so another lens is used during projection that either expands the picture back to its correct proportions or squeezes the image vertically to restore normal geometry. it should be noted that the picture is not manipulated in any way in the dimension that is orthogonal to the one anamorphosed. It may seem that it would be easier to simply use a wider film for recording movies. However, 35mm film was already in widespread use, and it was more economically feasible for film producers and exhibitors to simply attach a special lens to the camera or projector, rather than investing in a new film format, along with the attendant cameras, projectors, editing equipment and so forth. Cinerama was an earlier attempt to solve the problem of high-quality widescreen imaging, but anamorphic widescreen eventually proved to be more practicable. Cinerama preceded anamorphic films, but consisted of 3 projected images side by side on the same screen. The images never blended together perfectly at the edges, and it required 3 projectors. A 6-perf high frame, which required 4 times as much film, and 3 cameras. Nonetheless, the format was popular enough with audiences to spur studios to the widescreen developments of the early 1950s. A few films were distributed in Cinerama format and shown in special theaters. Anamorphic widescreen was attractive to studios because of its similar high aspect ratio, without the disadvantages of Cinerama's added complexities and costs. The common anamorphic widescreen film format in use today is commonly called scope or 2.351. Filmed in Panavision is a phrase contractually required for films shot using Panavision's anamorphic lenses. All of these phrases mean the same thing: the final print uses a 2:1 anamorphic projector lens that expands the image by exactly twice the amount horizontally as vertically. This format is essentially the same as that of CinemaScope, except for some technical developments, such as the ability to shoot close-ups without any facial distortion. There are artifacts that can occur when using an anamorphic camera lens that do not occur when using an ordinary spherical lens. One is a kind of lens flare that has a long horizontal line usually with a blue tint and is most often visible when there is a bright light, such as from car headlights, in the frame with an otherwise dark scene. This artifact is not always considered to be a problem. It has come to be associated with a certain cinematic look and is in fact sometimes emulated using a special effect filter in scenes that were not shot using an anamorphic lens. Another common aspect of anamorphic lenses is that light reflections in the lens will be elliptical rather than round, as they are in spherical cinematography. Additionally, wide-angle anamorphic lenses of less than 40 mm focal length produce a cylindrical perspective, which some directors and cinematographers, particularly Wes Anderson, use as a stylistic trademark. Another characteristic of anamorphic camera lenses is that out-of-focus elements tend to be blurred more vertically. An out-of-focus point of light in the background will appear as a vertical oval rather than a circle. When the camera shifts focus, there is often a noticeable effect where elements appear to stretch vertically when going out of focus. However, the commonly cited claim that anamorphic lenses produce a shallower depth of field is not entirely true. Because of the cylindrical element in the lens, anamorphic lenses take in a horizontal angle of view twice as wide as a spherical lens of the same focal length. Because of this, cinematographers will often use a 50 mm anamorphic lens when they would otherwise use a 25 mm spherical lens, a 70 mm rather than a 35 mm, and so on. A third characteristic, particularly of simple anamorphic add-on attachments to prime lenses, is anamorphic mumps. For reasons of practical optics, the anamorphic squeeze is not uniform across the image field in any system, whether cylindrical, prismatic or mirror-based. This variation resulted in some areas of the film image appearing more stretched than others. In the case of an actor's face in the center of the screen, their faces look somewhat like they had the mumps, hence the name for the phenomenon. Conversely, at the edges of the screen, actors in full-length view can become skinny-looking. In medium shots, if they walk across the screen from one side to the other, they increase in apparent girth. Early CinemaScope presentations in particular suffered from it. The first company to produce an anti-mump system was Panavision in the late 1950s. Panavision used a second add-on adapter lens that was linked to the focus position of the prime lens. This changed the anamorphic ratio along with focus position, which resulted in the area of interest on screen having a normal-looking geometry. Later cylindrical lens systems used two sets of anamorphic optics to achieve the required change in aspect ratio, one more robust squeeze system that was coupled with a slight expansion subsystem. The expansion subsystem was counter-rotated in relation to the main squeeze system, all in mechanical interlinkage with the focus mechanism of the prime lens. This combination changed the anamorphic ratio and minimized the effect of anamorphic mumps in the area of interest in the frame. Though these techniques were regarded as a fix for the anamorphic mumps, they were a compromise. Cinematographers still needed to be careful with their framing of the scene so that effects of the change in aspect ratio were not readily apparent. While the anamorphic scope widescreen format is still in use as a camera format, it has been losing popularity in favor of flat formats, mainly Super 35mm film. There can be several reasons for this. An anamorphic lens can create artifacts or distortions as described above. An anamorphic lens is more expensive than a spherical lens. An anamorphic lens is slower than a spherical lens, thus requiring more light and makes shooting low-light scenes more difficult. Because the anamorphic scope camera format does not preserve any of the image above and below the scope frame, it may not transfer as well to narrower aspect ratios, such as 4:3 or 16:9 for full-screen television. Film grain is less of a concern because of the availability of higher-quality film stocks and digital intermediates, although the anamorphic format will always yield higher definition than the non-anamorphic format. Anamorphic scope as a printed film format, however, is well established as a standard for widescreen projection. Regardless of the camera formats used in filming, the distributed prints of a film with a 2.391 theatrical aspect ratio will always be an anamorphic widescreen format. This is not likely to soon change because movie theaters around the world don't need to invest in special equipment to project this format. All that is required is an anamorphic projection lens, which has long been considered standard equipment. Other widescreen film formats are simply cropped in vertical size to produce the widescreen effect, a technique known as masking or matting. This can occur either during filming, where the framing is masked in the gate, or in the lab, which can optically create a matte onto the prints. Either method produces a frame similar to that in Figure 1, and is known as a hard matte. Many film prints today have no matte, though the film is framed for the intended aspect ratio. This approach is called full-frame filming, since most spherical 4-perf cameras retain the silent gate. In these, a film captures additional information that is masked out during projection using an aperture mask in the projector gate, and is known as soft matte. This approach allows filmmakers the freedom to include the additional picture in an open matte 4:3 transfer of the film and avoid pan and scan, by protecting the frame for 4:3, 2.35, 2.39 or 2.40. One common misconception about the anamorphic format concerns the actual width number of the aspect ratio, as 2.35, 2.39 or 2.4. Since the anamorphic lenses in virtually all 35mm anamorphic systems provide a 2:1 squeeze, one would logically conclude that a 1.3751 full Academy gate would lead to a 2.75:1 aspect ratio when used with anamorphic lenses. Due to differences in the camera gate aperture and projection aperture mask sizes for anamorphic films, however, the image dimensions used for anamorphic film vary from flat counterparts. To complicate matters, the SMPTE standards for the format have varied over time. To further complicate things, pre-1957 prints took up the optical soundtrack space of the print, which made for a 2.55:1 ratio. The initial SMPTE definition for anamorphic projection with an optical soundtrack down the side, issued in December 1957, standardized the projector aperture at 0.839, 0.715 inches. The aspect ratio for this aperture, after a 2x on squeeze, is 2.3468:1, which rounded to the commonly used value 2.351. A new definition was issued in October 1970 which specified a slightly smaller vertical dimension of 0.700 inches for the projector aperture to help make splashes less noticeable to film viewers. 4-perf anamorphic prints use more of the negative's available frame area than any other modern format, which leaves little room for splices. As a consequence, a bright line would flash on screen when a splice was projected, and theatre projectionists had been narrowing the vertical aperture to hide these flashes even before issuance of Penthouse 222106 to 1971. This new projector aperture size, 0.838 0.700 inches, aspect ratio 1.1971:1, made for an unsqueezed ratio of 2.39:1. The most recent revision, from August 1993, slightly altered the dimensions so as to standardize a common projection aperture width for all formats, anamorphic and flat. The projection aperture height was also reduced by 0.01 inches in this modern specification to 0.825 0.690 inches, aspect ratio 1.1956:1, to retain the unsqueezed ratio of 2.39:1. The camera's aperture remained the same, only the height of the negative assembly splices changed and, consequently, the height of the frame changed. Anamorphic prints are still often called scope or 2.35 by projectionists, cinematographers, and others working in the field, if only by force of habit. 2.39 is in fact what they generally are referring to, which is itself usually rounded up to 2.40. With the exception of certain specialist and archivist areas, generally 2.35, 2.39, and 2.40 mean the same to professionals, whether they themselves are even aware of the changes or not. Lens makers and corporate trademarks. There are numerous companies that are known for manufacturing anamorphic lenses. The following are the well-known in the film industry. Origination Panavision is the most common source of anamorphic lenses, with lens series ranging from 20 mm to a 2000 mm anamorphic telescope. The C-series, which is the oldest lens series, are small and lightweight, which makes them very popular for steadic cams. Some cinematographers prefer them to newer lenses because they are lower in contrast. The E-series, of Nikon glass, are sharper than the C-series and are better color-matched. They are also faster, but the minimum focus distance of the shorter focal lengths is not as close. The E135M, and especially the E180M, are great close-up lenses with the closest minimum focus of any long Panavision anamorphic lenses. The Superspeed lenses, also by Nikon, are the fastest anamorphic lenses available, with t-stops between 1.4 and 1.8. There is even one T1.150 mm, but, like all anamorphic lenses, they need to be stopped down for good performance because they are quite softly focused when wide open. The Primo and Close Focus Primo series are based on the spherical Primos and are the sharpest Panavision anamorphic lenses available. They are completely color-matched, but also very heavy, about 5.7 kilograms. The G-series, Panavision's latest anamorphic lens series, performance and size comparable with E-series, in lightweight and compact similar to C-series. Vantage Film, designers and manufacturers of Hawk lenses. The entire Hawk lens system consists of 50 different prime lenses and 5 zoom lenses, all of them specifically developed and optically computed by Vantage Film. Hawk lenses have their anamorphic element in the middle of the lens, which makes them more flare-resistant. This design choice also means that if they do flare, one does not get the typical horizontal flares. The C-series, which were developed in the mid-1990s, are relatively small and lightweight. The V-series and V+ series are an improvement over the C-series as far as sharpness, contrast, barrel distortion and close focus are concerned. This increased optical performance means a higher weight, however. There are 14 lenses in this series, which goes from 25 mm to 250 mm. The V-series also have the closest minimum focus of any anamorphic lens series available and as such can rival spherical lenses. Vantage also offers a series of lightweight lenses called V-Light. There are 8 very small anamorphic lenses, which are ideal for handheld and steadicam while also giving an optical performance comparable to the V-series and V+ lenses. In 2008 Vantage introduced the Hawk V-Light 16, a set of new lenses for 16mm anamorphic production, as well as the Hawk V-Lite 1.3x lenses, which make it possible to use nearly the entire image area of 3x 35mm film or the sensor area of a 16:9 digital camera, and at the same time provide of the popular 2.391 release format. Carl Zeiss AG plus ARRI, Master Anamorphics coming out in 2013, Cook Optics, Engineer coming out in 2013, Joe Dunton Camera, manufacturer and rental house based in Britain in North Carolina, which adapts spherical lenses to anamorphic by adding a cylindrical element. Its most popular lenses are adapted Cooke S2 per second 3, but they have also adapted Zeiss Superspeeds and Standards, as well as Canon lenses. JDC was purchased by Panavision in 2007. Elite Optics, manufactured by JSC Optica Elite Company in Russia and sold in the United States by Slow Motion Incorporated. Techno Vision, a French manufacturer that, like JDC, has adapted spherical Cooke and Zeiss lenses to anamorphic. Techno Vision was purchased by Panavision in 2004. ISCO Optics, a German company that developed the Aeroscope line for ARRI in 1989. Projection ISCO Precision Optics is a manufacturer of theatrical cinema projection lenses. Schneider Kreuznach, makers of anamorphic projection lenses. The company also manufactures add-on anamorphic adapter lenses that can be mounted on digital video cameras. Super 35 and Techniscope, although many films projected anamorphically have been shot using anamorphic lenses, there are often aesthetic and technical reasons that make shooting with spherical lenses preferable. If the director and cinematographer still wish to retain the 2.40:1 aspect ratio, anamorphic prints can be made from spherical negatives. Because the 2.401 image cropped from an Academy ratio 4:1 negative causes considerable waste of frame space, and since the cropping and anamorphosing of a spherical print requires an intermediate lab step, it is often attractive for these films to use a different negative pull-down method, usually in conjunction with the added negative space Super 35 affords. However, with advancements in digital intermediate technology, the anamorphosing process can now be completed as a digital step with no degradation of image quality. Also, 3-perf and 2-perf pose minor problems for visual effects work. The area of the film in 4-perf work that is cropped out in the anamorphosing process contains nonetheless picture information which is useful for such visual effects tasks as 2D and 3D tracking. This mildly complicates certain visual effects efforts for productions using 3-perf and 2-perf, making anamorphic prints struck digitally from center-cropped 4-perf Super 35 the popular choice in large-budget visual effects-driven productions. See also, Aeroscope, Anamorphosis, Aspect Ratio, Scene 160, Letterbox, List of film formats, Pan and Scan, Panamorph. References. External links, of apertures and aspect ratios. Widescreen Museum. Mitchell, Rick. The Widescreen Revolution. Operating Cameraman. Retrieved July 6, 2013.